So my talk is called Phoenix and the World of Tomorrow, because I watched too much Futurama, and I managed to get SVG of the Phoenix logo. But I want to just describe kind of at a top level, just so you know what you're investing into while I was sitting here, which is what this talk is actually going to be about, because my first draft of this talk was 150 slides and apparently a workshop, is a 10,000 foot view of what it's like to implement Phoenix and a web interface for emerging markets or places where we have low bandwidth situations. And I'm going to be showing some real code, some real metrics, but it's going to be more a guide of solutions you can look at and advice on an architectural level with some practical solutions that we've discovered while working at iwantmyname for this market. iwantmyname is a domain registrar based out of New Zealand. I have two colleagues with me. There's a Dave-shaped object, which is a New Zealand guy with a red hat. And there is a Nick-shaped object, which is a tall Australian man. It was very pleasant. So meet us, we are friendly. All right, so I want to talk a little bit about why iwantmyname started me down this path as I was doing the research. So in, I believe, July, we were congregated at our summit. And we were discussing the perils of the independent web in places like India or the Philippines, where Facebook and Google have just completely taken over. The internet is the Facebook in large, the internet is Facebook in large portions of the developing world. And there are reasons for that. Facebook invests a huge amount of time and money into optimizing for those markets. And we were doing the normal round robin discussion of, well, many people only have mobile devices and responsive design and generally like just normal bandwidth concerns and stuff like that. And then one of our founders, Paul in particular, Paul Spence, mentioned this can't be the only problem because every company would already be in there. And I thought about this for a while, and then I came back, you know what, I don't actually know the solution to this. Let me go off and I'll do some research. And this is the results of that research. So first I'm going to describe what the actual problem is, because I had abstracted it completely incorrectly when I first approached it, which was this is a front-end problem. It is and it isn't. So front-end, as we traditionally think of it, is HTML, CSS, JavaScript. And this is not entirely the problem, although many people research it this way. So first I'm going to just describe what the next billion users, which is Google's catchphrase, actually looks like. So right now, and it's really hard to track these numbers because they change monthly, which is there are about more than 3 billion smartphones active right now. In fact, I saw a number recently from, and by recently I mean this morning, which said there were 3 billion smartphones active in Asia alone. But that was from slightly questionable source, but but many of these users are also coming online for the first time. They've never seen a web page in their life. This is the first time they're experiencing the web. And they're experiencing it on their phone approximately across a 2G connection. It might be technically 3G, but they have 2 bars or whatever, but ultimately they're on a low bandwidth situation. Infrastructure is present, so they can rely on the internet being part of their daily lives, but it is slow. So imagine you had a dial-up modem in your cell phone. And that's kind of the experience that most people are experiencing the internet. And most people, these are now more users than people that are connected by fiber or LTE. The rate of growth is actually staggering. I was looking at new users online in India, and the last number I saw was 10,000 a day. And again, they get introduced to the online world via Facebook, similar to America Online in the 90s, and Google. And this is all the internet is to them right now. And this is another difficult number to pin down because telcos don't advertise their pricing scheme in an honest way usually. But the price of bandwidth is high, even by North American European standards per gigabyte, and it's also very high comparatively to cost of living adjustments. So every bit we send over the wire has an expense to it, and we have to be wary of how much data we're sending to these customers, because they work very hard to get this experience. And if you're sending a dumb cat GIF, it better be really good. So that is the user that we're thinking of. Now, how does this relate to Phoenix at all? Well, in Berlin, I think 2 years ago, Lance, I'm going to butcher his name, and I apologize because I've known him for years, Halvorsen, gave a influential talk, at least to me. Not so much it said new things to me, because I was kind of architecting this way anyway, but it said it in such a precise and concise way that it was more like, I can finally explain it. The hat goes on the head. So I would recommend very highly that you watch his 30-minute talk that's on YouTube from ElixirConf, Phoenix is Not Your Application, and also get his book, which is a vast expansion of that idea. But to just give the brief summary for those that haven't read it or seen the talk, is Phoenix is Elixir's, and any sort of Erlang product really, web interface solution. Meaning, there should be no business logic in it. If you have some sort of business logic that you need solved, make a smaller application that you talk to through some sort of interface or protocol that can allow your Phoenix application to be focused and very tightly focused on one problem, which is getting users through web interfaces to use your backend applications in a sane way. This is helpful for a variety of reasons. One simple one is it's easier to upgrade Phoenix when you need to. And two, it's good application architecture. And this has been present in Erlang for eons. Elixir does it as well. We should just do that. If you ever catch yourself writing too much in a controller or something like that, think about spreading it out to a new application. By Erlang's definition of application. So that's that, and this is my starting point. So from that point, and I started redefining how I addressed what is our application, or at least our web application. So it starts with Phoenix. Phoenix has a lot of things in it and needs to be tuned on a server somewhere. But the outer edge of it is not localhost. It's not somewhere in your data center. It's a real browser with a real user somewhere in the world. And you have to redefine those borders, because I remember a long time ago, there was lots and lots of blog posts about Phoenix that just showed the response time of channels or something like that. And it was in dev mode, and we all laughed because it was in dev mode, there's all sorts of stuff on, and it's much faster in production. But is it faster? I mean, in the case of, in a real application, the browser parses things. That takes time. And we don't account for that time. Phoenix is fast, the browser is slow. But that doesn't matter to our users. Users care what the final end time is. And it's important to have your end goal to the first point when your customer can start interacting with you. That's when the application happened. Before that, it's just a bunch of numbers of different stages in the pipeline. And when I started redefining that, and as another note, Phoenix presence already kind of acknowledges this app architecture. It is essentially eventually consistent browsers. And in that case, we already are kind of designing this way. You just have to think about it. So I use a tool called SpeedCurve. Now, SpeedCurve is a company which allows you to replicate connections and shows you a film strip of how the browser has parsed it, and you can replicate certain conditions, i.e. if you want to, say, an Android phone on a 2G connection with 30% data packet loss in Nepal, how does my browser get parsed? And they replicate that for you. And you can set it up in multiple ways. This is kind of a long polling way where it checks every day. And you can see what's going on in your budgets and everything else so that you know what decisions you've made in your application to that affects users in a less than ideal situation. So I recommend using SpeedCurve. This is not a paid ad, although I'm not opposed to that if anyone from SpeedCurve is watching, but that's a different thing. The other thing that I had to consider is mobile first design, and I don't mean that by a skinny browser, which is how we normally start in like CSS land. I mean, go out and buy a low-end Android phone. Google recommends a Moto G4. They are super cheap. I have an older Sony Xperia, and I always keep the bandwidth on that phone when I'm doing my testing to 2G max. In fact, every once in a while I put it down to 56K modem for funsies. But this is important so that you understand when you hold a real device, not just numbers, what it feels like. Like, it's something which is hard to describe, but it's essentially app feel. So you're walking down the street on the 2G connection. How long does it take me to get something? Can I walk and talk with this, or is this something I sit down with? And it helps you make informed design decisions on multiple fronts. So, and there's another thing of how we started establishing budgets. So there are two major budgets which are easy to understand. Time, which as I said is when the browser gets it, and footprint. And just for fun, we do this in units of doom. So there was lots of articles way back in the day where people were worried that websites were getting larger than the 1990s game Doom, which was 2.39 megabytes. A Wired article today is about 6. So to read one Wired article, you need 2 Doom units and a bit. And so this is fun around the office. I picked an arbitrary number, but now we talk about units of Doom every time we add a React library. Like, this is accordion, it's half a Doom unit. This sort of thing. So it makes it a little more fun because honestly it's boring, it's bits over the wire, but use at your own risk. The other one is time. So not all bits are created equal. Everything on your page must do a job, and a job can be selling your product. Like if you have a big hero image, that might be worth spending some bits on. And also, JavaScript and images are not equal. Images parse really fast, JavaScript takes a while. So pay attention to when the browser has finished parsing, not to what the bits are. And there's another thing which is, when the page loads, you can deliver an experience to your customer, but you can also have a fully appreciated experience as more and more JavaScript loads if you design your app accordingly, instead of blocking the page. So if you work with an appreciated experience that's slightly transparent to the user, they will get a better app as their data catches up with them. And I recommend this as an app architecture. All right, so I was being funny, but we're running low on time and we're all hungry. So this is a Bible quote about us buying a server. So just let's move on. So one thing we did notice when we're doing our budgets and for time is that when you move Erlang to a bare metal system, you get this dramatic speed boost. And this dramatic speed boost is surprising how much more stable your system gets. And literally, it's noticeable on the browser side that you move the server to an equivalent size, but it's no longer a VM. That's a bit above how I understand things, but just I recommend Erlang is a VM, ship it on a server, a real one. And there is many companies right now that are making that really easy to do. And the other thing is, we used to have something we called we used to call them network quakes. And we couldn't tell where they were coming from, but essentially we would have a noisy neighbor on the same physical hardware that we couldn't tell. And we would have these weird disconnects on our WebSocket. As soon as we went to bare metal, they went away. That ops cost vanished. And they're not that expensive. And I bring up this one server which is new to me, which is by packet.net. So this is 96 physical cores at 2 gigahertz on ARM. It has 128 gigs of ECC RAM and some other stuff which matters less. And it's like $350 a month. This thing is nearly designed for Erlang. You can have all the ports you want and nearly infinite number of cores, or 96 to be precise. But we haven't tested as much with it as we would like to, but I would recommend looking at it. So packet.net, it's called the C1 large ARM, and it has a fun pun in it, which says time to start an arms race. So Intel alternative. So our OS and file system of choice, FreeBSD and ZFS. Just do it. Networking stack in FreeBSD is better. ZFS caches a lot of your application into RAM. Don't have to worry about disk I/O reasons. I really did want to be the guy, use whatever operating system you want, blah, blah, blah. I've seen Ubuntu in production, and I've seen FreeBSD in production. I value my sleep. FreeBSD is more stable at the end of the day. And tracing the networking is much easier. And the ZFS, I was very surprised at, again, a noticeable speed boost in browser from, what was it? Compressed ARC, which is basically your application getting loaded into RAM on demand, and it stays there while your application's running. So at iwantmyname, we use HAPROXY for our web server. And by web server, I mean proxy, because Cowboy is a very good web server. I am a fan of HAPROXY because it's very light and does the one job I want it to do that Cowboy doesn't, serve SSL certificates, proxy, and give me a little bit of a cluster. But you could use Nginx. I found that Nginx needs a little more tuning. But again, the point is that it's very light, it does very little, and moves the data along. This was another bigger one, which is compression. So I pulled this stat because I was surprised by it. So Netflix, a company that core product doesn't need to be compressed because it already is, turned on GZIP one day, and 43% of their bandwidth costs went down. This is only from them sending subtitles, HTML documents for whatever they're doing, that sort of stuff. And that was kind of unnerving, but again, turn it on. And then, this is me making the face. Then I moved on to implementing it on our own. And GZIP is ubiquitous, but so is BROTLI, which I was surprised by because it was new in my head. But it's 87% of the browser market has it. It's HTTPS only. It can be slower, but there are a lot of guides online that are misleading about that, and it isn't really. So the fundamental difference between GZIP and BROTLI in default mode, GZIP compresses at GZIP 1 by default. BROTLI dials it to 11, and that's literal. BROTLI's highest compression is 11. And thank you to whatever developer did that, that made this slide much easier. But what you can do with BROTLI, and this is what I would recommend, GZIP 6 and BROTLI 4, no, it's the other way around. BROTLI 6 and GZIP 4, BROTLI and GZIP have the same amount, it's around the same speed. BROTLI is a little faster, but it's about 3% higher compression for, I was compressing a CSS file. And you can do this live and at almost no cost, comparatively to gzipping. Now, what I would also recommend is for your static files, like CSS, JavaScript, blah, blah, blah packages, compress it with Webpack or whatever you're using to compile your assets. When you do that, you can compile it all the way to 11 at no cost. And it's going to be a little bit of a cost on the browser, but it's a fast preference over doing it over the wire because BROTLI at 11 can get the compression to about 93%. And this just saves on bandwidth, which is the expensive factor in this situation. HTTPS, in matters of compression, has a mild problem, which is there are a few exploits. So we wrote a very small plug, and we wrote a very small plug in our application. We decided to open source it because we were hemming and hawing because it's literally this. It's 3 functions. It's essentially Elixir flavored Erlang because Dave and I have been hanging out in Erlang land too long. But it's 3 functions piped together. I'm not a huge fan of making that a library because it is just 3 functions. It's a blog post. But we made it a library for the good reason that this shows the power of the VM. I didn't have to write anything. All this does is put a wobble in our HTTP header so that it's harder to exploit via compression our web server. And this took 3 or 4 minutes to write, and I didn't have to pull in any libraries or anything to that effect. Just a little bit of wisdom, barely touching the plug stack, and it was done. So this is on Hex like today. It's called Harfleur, and poke it. I would be interested to see if anyone could make a 2 Erlang version of it, because I consider this to be like Erlang Golf. Next, WebSockets and compression. Okay, so this one, there be dragons. I spent too much time on this. So this is a compression of the Raven in GZIP. It's just a visualization of how GZIP will take native language and start compressing it. Now, the reason I'm bringing this up with WebSockets is WebSockets in Cowboy 2, so when you import that into plug, has a WebSocket per frame compression algorithm. And the way it works is you have a hash which per frame persists. And it slowly gets more efficient the more frames you send across it. I went down this rabbit hole for probably a week. And there's some interesting bits. It costs a lot of RAM for our very light WebSocket connections. It's about 300K per connection. And when there are disconnects, you lose, basically the RAM is freed, and then you have to do it again. So you have to evaluate how long your WebSocket is sitting around and do that. This is a very much it depends, and it's newer tech. So I would just say you can compress a WebSocket if you're somebody like Slack, where you're sending messages all day for 8 hours. It's probably a very good idea. But if you're just connecting to a WebSocket for like a minute, maybe think about how much ops costs it's going to cost you. So anyways, that's that. And now this is my own joke. Wait, isn't this a Phoenix talk? Because I haven't talked about it yet. And here we are. So this is just some advice. So Phoenix templating. EEX is both very fast and very good. You can kick out web pages at an alarming speed. You should use it. I get really sad when I go online and I go to a new Phoenix app and I turn off JavaScript and I get a white page. Please, ship an HTML template. It costs you very little, particularly with the compression. Care about your HTML semantics. This is something of a personal thing with me, but screen readers rely on clean HTML. And in the developing markets, people, because of translations and possibly poor idiom, will be using HTML semantics to make sense of our apps if we are not making sense. So care about it. Spend some time with your content media strategist. Spend time thinking about what does this mean. I know it seems silly, and it's by definition a semantic argument, but it helps people. So just think about it. Get text, same advice. It's very fast, it's very good, use it. And we have a plug which reacts to, and please do this, don't do it by IP, the browser's set language, which will start adjusting, which will set our flags. This drives me nuts with the IP thing, because when I'm in Greece and I'm looking up technical articles, I do speak some Greek, but at the same time, I do not speak it to the point of being able to analyze technical articles, and Google will just feed me Greek articles. And it takes me a while to find the English ones. So do it by the browser's settings. And be able to call it with some sort of flag, or in our case, subdomain. The reason I'm saying soon is we wrote the plug. There's another plug if you look up online. We disagreed with some of the decisions in there, so we wrote a different one. But it's kind of hinky code at the moment. So I'm cleaning it up, documenting it, and putting in, actual testing. So soon on a Hex. Now the next one, CSS. And this is my favorite CSS thing right here. CSS, what is it even? I've never seen so much trouble with a programming paradigm than CSS. So but there's two things about this notes. So CSS is awesome. It's outside the box. I've spent a few hours debugging that. But if you had a design system that couldn't put things out of the box, you would have table-based websites. So it's a part of the deal. You have to deal with that. Now, the CSS Peter Griffin thing, which I'm going to play again because it's fun. Yes, this is how I debug. But this is also how I debug in a REPL. This is every form of debugging. It's just CSS gets a bit of a bad rap because we all have to do it, and not all of us have the same competencies in it. But I could replace CSS with legacy Rails app. Or I could replace it with legacy any app. And you have the same image. So perhaps if your CSS is really hard for people that aren't heavily skilled in it, perhaps it's time for a refactor. Just soapboxing a bit. But CSS, how it actually works. This was an attempt to kind of explain how the parser works in Elixir. So there are two things of note here. The struct for browser.css has a 5-tuple in it, even though it's a struct. But that's basically how CSS understands specificity. Almost got it. But you have, they're in order of importance. So important outclasses everything. Inline outclasses everything behind it. IDs outclass that, classes, and then elements. And these numbers add up. So it's a little bit of CSS math. Oh, I have 3 classes and 2 elements. What decision is it going to make about these particular key values? That's how it functions. And then the next one is, this is how the browser parses CSS. So we all know about the DOM. I find less people know about the CSS object model, which is the DOM with the CSS inheritance calculated from specificity. I didn't nail it that time. Then it goes to layout. So layout is the box model from the CSS is awesome. Then it does paint, which is fonts, text, color. That's why you can do the CSS awesome thing. So if you are refactoring your CSS to be faster, you need to understand this. There are lots of articles. Just look up CSS object model. That's what those articles are about. Optimizing your pipelines for assigning values to DOM elements. CSS class-only design. Now, this is actually a really good idea. It's by Harry Roberts, and he writes a lot on it. So he has this inverted pyramid, which is essentially the CSS cascade. So imagine Erlang functions inverted. You get the same idea. It's a pattern matching system that's declarative. So he organizes everything that way. Then you have block element modifier naming structure. The reason he does that is because he's not using specificity anymore. He's only using classes. And this produces high quality semantic CSS through process. It also boils down CSS to just one programming vertex. You don't have to think about specificity as much. You just think about how to organize your pipelines. So this is Harry Roberts. He's CSS Wizardry on Twitter, et cetera. His website, if you want to dig into this as a process for your company, this is a very good idea. CSS, why I ignored good advice. So I did something else at iwantmyname. So normalize, but for a brand. So normalize.css normalizes CSS oddities between the browsers to a convenient stack. We did the same thing, but we did an element-only style, with one exception being buttons, because buttons are conceptual. Sometimes you have a GET request that's just a link, which is a button. But these element-only style is basically our default page. If you were to delete all our classes, with the exception of button, we would still have a branded page. There are very few media queries. It's only line heights and a couple of restrictions so that it's still legible. There are 0 external dependencies, no fonts being loaded other than what's on systems, no background images, nothing. It is only what the DOM can render freely. And then why? The backend is not an unmovable block. If we're in a low bandwidth situation, either that we can detect with JavaScript or we can explicitly call, We can ship that on the top of the page, not even in a CSS file, with one HTTP request. And our customers get something immediately, which is legible and branded. We have a low bandwidth of the site as a consequence. Again, zero external dependencies, because that's important. We did write a plug to explicitly call this also soon, TM, because I'm not that organized. But the other thing is, nope, I'll leave the JavaScript slide up. But the other thing is, when the hurricanes were happening in the States last summer, CNN released a text-only version of CNN. And this was vital to a great many people because cell phone towers were going down, low bandwidth. They needed to be able to read the news to know where to go to be safe. And I admired that because often we think of our apps as something extra. They exist on our laptops. But sometimes our apps are vital infrastructure, and we should think about people trying to use it when situation is not clear on how much time they have. So we ship the low bandwidth version of our guides because it's useful if you don't have a lot of bandwidth, you're on the subway train, you could read our guides. We are domain registrar, we are not vital infrastructure. No one in a hurricane situation is trying to change their DNS entries. But the principle is the same. If you use Slack to communicate with your family and you're in a war zone or something, it's very important that they have the ability in a low bandwidth situation to be able to use your app. So, advice, aside from that. JavaScript. This one, I always make a groaning noise, so the only advice that I can give, because JavaScript apps change so fast without knowing what's inside your JavaScript app, is try breaking up your app from slow moving to fast moving. You can usually tell that in the Git history, just don't bundle it all up in one. A couple extra bundles and you take advantage of caching. So if you have a part of your app that doesn't move very much, probably put it off in a corner. And then consider JavaScript and WebSockets as an appreciated experience. Try to load them after your initial CRUD app has loaded. And if you can do it transparently, i.e. use the same CSS, but suddenly new data is flowing in when the JavaScript arrives, that is a good programming paradigm. That people won't notice it, it stays out of their way, and they get a better experience no matter what situation they're in. And as all things, when it comes to front end, it depends, Shruggy. You need to analyze what's going on here. But ultimately, this is how we used to design web pages when I started in 2008. All advice about web pages was exactly this, before JavaScript engines were fast and all of that. And this is a lot of kids get off my lawn. I've been saying this for years, but now it's important because we're again in a low bandwidth situation. It's no longer JavaScript is expensive to parse, but it's now JavaScript might not arrive. So, and as an Erlanger as well, this is just good fault-tolerant architecture. Like, we know networks are bad. We have multiple fallbacks for networks are bad. Do it on the front end. Networks are bad. Not everything shows up. Can we still deliver something of value? And this is me every day now. I'm going to assume the children are wrong. So anyway, that's it. We can go to lunch. Thank you for listening to me right before lunch. If you have additional questions, please email me. I will happily answer some of them. If it's a React question, I will answer crankily. iwantmyname is also hiring a new dev. You want to join us on this new journey into developing markets? Please meet the various iwantmyname objects. Kiwi accent, Australian accent, I have a beard. All right, that's it. Thank you.